So my name is David Arterburn. I'm the director of the Rotorcraft Systems Engineering and Simulation Center at the University of Alabama in Huntsville, Alabama. And this is the UAS Development and Integration Lab. The mission of the lab is to explore new designs and new technology in UAS platforms. Not only typically we look at sensors and other things, and there's many people doing that, but we're looking at the total integration of UAS and how that can be used for the public good and the benefit of society. So the UAS Development Integration Lab really has its roots for a long time at the University of Alabama in Huntsville, where many of the different departments were doing unmanned systems, but none of them really had a strong program in and of itself. They were doing individual work. So the university, as the FAA became more involved and needed to register and have programs for drones in order to ensure the safety of the public, the university decided that they needed to have a centralized place for unmanned system integration. So since the Rotorcraft Systems Engineering and Simulation Center had been doing that work for many departments and flying some of these assets, it was a natural fit for us to start establishing those. So why was that important? Because we competed initially for one of the FAA test site slots of the 6 that were selected. Fortunately, we didn't win that competition, but we learned a lot about the integration. We learned a lot about the FAA, and so shortly thereafter, they ran a competition for the FAA Unmanned Systems Center of Excellence that was going to help the FAA work on integration of UAS into the National Airspace System. And so we were able to partner with Mississippi State and 21 other universities, and we won that competition in May of 2015. So the lab really got its roots long before that time, but it really started moving forward aggressively in May of 2015. So the lab is fairly new at this point, but we are one of the tasks we're running right now is the ground collision severity task for the FAA, where we're looking at what happens when drones of different weights might fall on the public. So if you're flying your unmanned system over a group of people, then what might happen as a result of that? Is there a death? Is there just an injury? And so we've been running that evaluation for the last 6 months and doing a bunch of analysis. Well, recently we did a series of analysis and briefed the Micro UAS Advisory Rulemaking Committee about those results. But as we looked at those results, we realized that we really hadn't validated anything. Everything was in analysis form, and so we felt like we needed to go out and demonstrate our capabilities. So we took one of these small platforms, we modeled it in computational fluid dynamics, and we actually ran drag studies to look at the drag resistance to actually analyze what the terminal velocity of these vehicles would be if they dropped from the current 400 feet, which is the upper limit of the vehicles under the current FAA rules. And so we looked at that and we got some drag coefficients, updated our analysis, but we still hadn't done what we thought we could do in terms of really validating it. There was a clincher. So we took this particular vehicle up to 400 feet, put a parachute on it, and then we turned the motors off. And we let it fall, and we built a special instrumentation package for this particular vehicle to record all of the data on the way down, and then pulled the parachute at 50 feet, saved the vehicle. But the data was very interesting. It allowed our data and our analysis that had been refined by CFD. It hit right smack in the middle of where our calculations had shown. But now it's compelling. Nobody can turn around and say that this is just analysis, it's theory. It's not. It's real science. We've used the science, and now we've backed it up with a series of flight tests, and we're going to continue to do those flight tests in support of future efforts for the FAA. And we're also going to look at now what happens when at those energy levels when you actually collide with something. How does the vehicle break up? How does energy get transferred to humans? We've done that analysis in conjunction with Mississippi State and Embry-Riddle University, but now we're going to go out and actually do the flight tests and validate their models with actual flight tests. So the lab is instrumental to that because of a few things. One is it ties analysis and theory to real flight test, and so now you provide the FAA with the tools to look at a broader scope of vehicles, not just one, but at the same time now you're able to go out and do the tests that are necessary that become fundamental data to look at how do we make these designs safer, how do we make them more effective to operate in a public environment without risking people on the ground. So the purpose of this thrust stand is to be able to evaluate motors and prop combinations and figure out what the best design parameters are between the two. You have to be able to record power, thrust, current draw, in order to better understand the design and how it's interacting. With this data, we can go into design tools and start looking at optimizations between propeller design and motor combinations that ultimately achieve our purpose-built design objectives. So we have a strong connection with a number of the departments, the Earth Systems Science Center, the Mechanical and Aerospace Engineering Department, the Systems Engineering and Engineering Management Department. Many of those departments are already aware of our activities in this particular area, but we collaborate with faculty and students in areas that are of interest to them. We also stood up one of only 6 UAS student chapters that were sponsored by the Association of Unmanned Vehicle Systems International, AUVSI. And our chapter here has largely been the most dynamic, and recently was asked, we had 15 people attend the symposium, was funded by AUVSI, so 15 students from UAH went down and attended the symposium and were exposed to hundreds and hundreds of vendors and new products that they would have never had an opportunity to look at. So those interactions, we try to look at student designs that we can offer to the students and get their interest in areas that are of value to nationally or to society, so that they can look and explore the designs and be unencumbered. We also look for student designs that are part of their senior design courses, where we offer things that are maybe of difficulty to us. We think there could be a better design. We offer it to students to go explore that design. And one of those vehicles is a larger vehicle where we did the Department of Homeland Security, did a test of a number of vehicles to look at what could do their 7 missions fundamentally that they fundamentally have. And 5 of those could be done by fixed wing. 2 of them they determined had to be rotary wing or vertical lift. But there was no one vehicle that could bridge all the gaps. So we looked at that output and said, wow, we think we can build a vehicle that can bridge both of these specification gaps. And so we did. And so we took the various technologies we needed to do that, and we gave students design projects that were centered around that. So they designed, fabricated, and constructed those as part of senior design projects. Then we took the results of their projects and have integrated it into a complete vehicle that we hope to test this summer and show that we can bridge the gap between rotary wing and fixed wing platforms. So the part of it is to get exposure to what we're doing here. We work with these large universities, 21 universities, as part of the FAA UAS Center of Excellence, and we're learning from them and how those students are responding. But we're reaching out right now to look at training opportunities for students, so that students that are here getting their aerospace degree can also come over and learn how to fly, how to become UAS pilots, not only in the small vehicle range, but for large vehicles as well. So we're partnering with some folks in the local community to develop a training capability that starts them at small vehicles like the Phantom and then moves them up to larger vehicles and larger platforms, because they understand the sensor, the ground station, the data link aspect to unmanned systems, and give them that broad knowledge. But we're also reaching out in STEM activities, where we reach out to high school students and junior highs, where we do first Lego League and first robotics competitions. We lend them technical support, and we are trying to look this summer to start training teachers in those institutions so they are aware of how to program. Many of them are history teachers or English teachers that are running these programs to the benefit of the student, but they don't really have engineering expertise. So we bring them in, and we're going to bring them in and show them how to program and what the students are doing, so that they're not just, they have some awareness of what the students are trying to accomplish, and they can run a more effective program. So we're trying to reach out with students and faculty in that area so that we can promote better growth of robotics and unmanned systems in the community. So we think that will ultimately result in more students coming to UAH and more students interested in this growing industry. Right, so if they want to contact me, they can go to our website, which is rsesc.uah.edu, and my contact information's there. There's also information about new and innovative things that we're doing within the center, and that we're doing specifically for unmanned systems or vertical lift technology. And so people can keep track of us there. There's also a place called sureuas.org, which is the organization that's the 21 universities that are working for the FAA UAS Center of Excellence. That particular website can give them insight into what all 21 universities are doing to help the FAA integrate UAS into the National Airspace System. I think this is a fabulous industry that needs to move forward, and I really like to see Huntsville become the center of that. In 1959, when von Braun and his scientists moved to Huntsville, we became Rocket City. And so Rocket City, we're still keep that pedigree, and we're still very instrumental in that industry. But now unmanned systems have the potential to grow like missile technology did in the 1960s. And so I'd like to see the University of Alabama and Huntsville and the Huntsville community be part of that growth. And we want to be partners with industry, government to look at how we can make that a reality.